take our seats. My name is Jacques Couvillon with the National Board of Boiler and Pressure Vessel Inspectors. It is my pleasure to be with you today and to have the opportunity to introduce someone who really cares about clients and thrilling them. As the Director of Product with the National Board, I share in that passion. Mark Travis helps business leaders see beyond technology to accelerate profitable growth. He has a broad and diverse personal and professional background, which includes software development and engineering, product management, marketing, and organizational change management for Fortune 500, as well as Inc. 5000 companies. A senior leadership and board advisor, researcher, executive educator, and author, Mark is internationally recognized as an expert on strategic factors that result in profitable growth, sustained innovation, and lasting change. Mark has helped organizations create tens of millions of dollars of value and build products that thrill their clients. He has worked with organizations including the Fortune 10, being on the founding leadership team of several startups. He has a unique passion for business that is grounded in 30 years of continuous learning. Mark has worked with several international teams and has traveled extensively around the globe. He is an avid veteran pilot and aircraft owner with over 1,000 years flown extensively throughout the United States and the Bahamas. He has a BS from the University of Maryland and an MBA from Emory University. He writes extensively and speaks about organizational performance, strategy, and new technologies. Please help me welcome Mark Travis.
Thanks for that kind introduction. And by the way, it's 1,000 hours, 1,500 hours now, not 1,000 years. I wish I had 1,000 years of flight experience. That would be fun. So let's talk a little bit about Industry 4.0. I know a lot of welders in small companies, and I fly with one gentleman who owns a steel tank company, and I asked him what he knew about modern technologies, and he's like, I got 4 or 5 welders, and I do steel tanks. Hopefully I can inspire you to think differently about this, because a lot of people are thinking about this. So let's do like a brief background here. Let me just see if this will work. So the first industrial revolution was powered on water and steam. So instead of having to use all these hand tools to saw, put things together, they figured out how to harness a river and use that motion to turn the wheels to run all these pieces of equipment. It's kind of dangerous if you think about it. You've got like all these machines are operating at the same time, unless they have clutches in between them. So, but it really accelerated the amount of furniture they could build, or anything else. So electricity came along, AC electricity, Tesla, invented AC electricity. So now you could have motors. They had DC motors before. AC was a little more efficient. But instead of having one gigantic contraption, water, steam running, all these pieces of machines, you could now put these machines exactly where you needed them, or you could use one at a time. That greatly, reduced energy, reduced costs. You can now use electrical power to make whatever you need to make. Then came wide-scale manufacturing. Henry Ford Model T. People realized, hey, if I concentrate on one widget and have it assembled somewhere in mass, then people can specialize, and I can make a lot of product. So instead of making everything individual, bespoke, I guess, they could make thousands of them, any color you wanted as long as it's black. So the fourth industrial revolution is technology. So what is innovation? Let me put this thought on you. Some of you may already realize this, but answers are everywhere. They're all hidden in plain sight. And I say hidden because unless you know the right questions to ask, they're going to remain hidden. The answers are always there. It's the questions that you pose that come up with that idea. Bear with me 1 second here. My brain went in 3 different directions at once. So you have to ask those questions. It's because of the pressures that exist in your business. So pressures are, hard to feel. Let me talk about hard to feel in a minute, actually. But these are these things that you're like, man, if only we could do this, it would solve these other problems. And when you invent something, everything goes through this peak where everybody thinks it's the best thing since sliced bread. Right now, that's NFTs, non-fungible tokens that are on that are being traded. Nobody really knows what they're for, but they're really excited about them. But now they're sort of going through the trough of disillusionment because people are stealing them, they're faking them. I think it's actually going to, that piece of it's going to end in the crash of uselessness, as opposed to the trough of disillusionment. But eventually you get to this point on the curve where things start coming back up. People say, this is a good idea, but it would be better to use it over here. And here's why. We thought of this idea that'll, it'll increase profits, make it easier to attract talent, something along those lines. And you go through the slope of enlightenment. And then, plateau of productivity where it's sort of like, okay, now we're on this new level of productivity. So like the iPhone, when it very first came out, version 3, well, that was the iOS, but no one really knew what to do with it, so it just became kind of a games platform. But people started thinking about, what if we could monitor devices with it? What if we could, monitor our corporate data with it? Digital resilience is something that is a way. Think about the 70s, 60s and 70s mainly. They had these big monolithic systems that ran companies. And if you changed one piece of it, you had to regression test the whole entire chain from beginning to end to make sure it still worked. Eventually, they started realizing that you could build little modules that were replaceable. So you could pull one out, put another one in. You didn't have to regression test the whole system. You just had to make sure that one piece works. So that's another building block to think about when you're thinking of an industry, in the future, using those technologies. Try to encompass it in one small area that that, if you pull it out, the rest of the system can still run, or you can upgrade it. So there's a story about a king many, many years ago, and he loved to play chess. And he loved to challenge people to chess because he just, he was really smart at it and really good at it. Well, a sage came along one day, and the king challenged him to a game of chess. And the sage was pretty smart. He goes, well, okay, if I win, I just have one request. And the king's like, say it, because the king knew he was going to win. He goes, I want you to place 1 grain of rice on the first corner of the chessboard. And each additional chess piece, chess block, I want you to double it. So, you got 1 grain, 2 grains, 3 grains, 4 grains, etc. The king was thrilled. He's like, man, this guy's got like some modest, means of winning. And so they played the game. The sage won. So he was like, okay, my accountant will get your winnings, and so sage came back after about a week and said, why haven't I been paid? And the king summoned his accountant, and he was like, what? Why has this guy been paid? He won the game. He goes, well, sir, I started doing the math, and I realized that before you even get halfway through the chessboard, that's more grain of rice than we even have in our kingdom. And by the time you get to the end, it's enough rice to cover India in like a foot of rice. So we don't have enough money to pay him right now. So the king, there's 2 ways that story ends, but I'll tell you the nice thing. So the sage agreed to have payments over time, compound interest. So he's now very, very wealthy. The other part of the story is he had a guy killed and took care of the problem. That's kind of fun. So here's another thing to think about. Moore's law states that technology doubles every 18 months. And this is back in the late 50s. So every 18 months, how many 18-month periods have we had since the late 50s? Same concept. You're on an exponential growth path. So when you first started thinking about this, it was like a tree trunk technology. Then branches started coming out, and so you've got you still got something you can kind of put your mind around. Well, now technology is like this big tree with thousands of branches and millions of leaves. And it's still doubling every 18 months. So technology is marching forward, you know, whether you think it is or not. And so, you know, there's a good graph. So what technologies are driving Industry 4.0? This is pretty much the core, and if you dive into each one of these, there's more technologies that support that. But in general, big data, the ability to collect big data is the #1 driver. The Internet of Things. So throughout the years, you've had things called PLCs, programmable logic controllers, that, you know, embedded in automation. Now you can put all these little sensors into Internet devices so that you can collect that data over the Internet, put it somewhere, and analyze it later. Those can be temperature sensors, acceleration sensors, you know, you name it, there's a sensor for it. Robotic process automation. So you may think of that as, you know, robots that are manually doing things and putting things together. Well, there's also robotic process automation that will automate things like receiving accounts receivable, so that you have a ERP system that you've got, you know, things that happen automatically every single month. Well, there's a robotic process that can control making all that happen instead of paying some, you know, temp or, you know, low-level person to do all this repetitive labor every single month. Drones have become very widespread. It's just amazing what they can do. Just a few short years ago, you know, you could barely lift, you know, 4 or 5 ounces up in the air and keep it going. And now they've got these big drones. I've actually seen one drone that has like 8 motors that a person stands on top of and drives around. I'd hate to fall off that thing, because that would, aside from all the blades moving, you know, but drones can do just about anything these days. And then of course you've had mobile. We've all been able to witness, you know, the iPhone and Android devices just proliferate and increasing capabilities. And then the final thing is blockchain. I'm going to talk about that towards the end, but that's probably one of the most fundamental changes of thinking that I think you guys would be very interested in. So, what does Industry 4.0 promise us? Because like I said, unless there's a business case for it, a business reason, or some way to think about it, it's not going to make a whole lot of sense. What you want is interoperability between these machines and the people. You know, in the beginning, if a person could create a piece of furniture with his bare hands, they would do it, right? They can't, they need tools. You need to have a tool that increases the productivity of that person, otherwise, why do it? That's the reason why these machines are going to be out there. And I'll show you an example in welding, for instance, of using machines and sensors to maybe make a better welder or keep track of your various assets. Virtualization and simulation are ideas of duplicating something electronically that's in the physical world so that you can run simulations on it and see how it would respond. And you have to be very detailed. Sometimes it may be as much as, you know, what would happen if we raise the temperature of this input 5 degrees? And it feeds through the system and comes out, and you realize that, you know, there are a multitude of ways that that'll affect the system that you might not have thought about if you'd gone into your actual physical system and increased the temperature 5 degrees. Very cheap, it's non-destructive. Decentralization of decision making. So let me take a minute to talk about decision making in machine learning. If you've got something that always results in 4 different options, there's no reason why you couldn't recognize those patterns and have the machine make a decision. So maybe something complex that, you know, always results in those 4 things, and there's no need to have a human doing that anymore. So it augments the human. They don't have to make those decisions anymore. They can concentrate on higher level things to think about. So real-time capability to collect data in the, you know, 70s and 80s. You know, sometimes you get, let's just say, marketing data. You'd only get it like maybe once a week, once a month. So that's a long time to wait to learn if your advertising campaign, is working or not. Even, with any number of things, you had to wait to get the data. Now the data is available right there. Like I said, the answers are everywhere, hidden in plain sight. If you can instrument it, you can get that data. Service orientation, there's now Internet of Services that these companies provide. Many companies specialize in providing a way to massage your data and give it back to you. So instead of having a team of programmers or engineers designing something, you can you can have them maintain those engines for you, and they have the expertise to make them perfect. Where you may have a small limited team, but you can concentrate on your core competency instead of having to build all these little widgets. And then the modularity we talked about earlier. So we talked about the pressures of ideas and how you need to ask the right questions. Let me put another concept on you. It's one I've learned recently from a professor in North Carolina. It's called constructal law. And I'll give you the statement. It's kind of crazy, but in order for a finite system to live, it has to grant equal access to all of the underlying currents, and that could be electrical currents, heat, whatever. But it's a thermodynamics concept that controls. He found this out by monitoring heat patterns in the electronics he was building. But when you look at it at a big picture, it's the same process that controls the way a lung looks, the way a river basin looks. All of these complex tissues, solar systems, they all look the same because they all follow this constructal law. So what does that mean in business sense? I had to break it down because that still didn't make a whole lot of sense to me on finite systems. But think about it. I'm sure all of you remember the Sears catalog from way back when. Most of you do, I think. There's a few younger people here, but you go through this catalog and you do research on something that you wanted to buy, and there was the good, better, best, I guess, in there. And if you really wanted to learn more, you had to drive to the store, and there may be several stores you had to visit. You ask questions of friends, and you've got to burn gas, you've got to burn time. It may take you 2 weeks to eventually buy something. Now we have Amazon. So you can basically go to a website, see what other people recommend, buy it, and it's in your hands in 8 hours. That's a compression that follows constructal law, which means that there's something that people want to do, and they want to do it now, and they're going to do it in the most expedient manner possible. So if there's something that's blocking that process, eventually, over time, it's going to flow into the ideal state. It's still kind of crazy to think about, but let me give you another example. Hartsfield was built with this idea in mind. So the Hartsfield in Atlanta, where all the airliners go. What they did is they created like a main artery that goes right through, the middle, and that's where most of the people, it's where all the people come and go in the middle. Then it branches out. There's like 6 gates, rows of gates. There's the train system. There's the moving sidewalks, and then there's the middle piece. But it's amazing that I can park at Hartsfield-Jackson and not really stop. I don't interrupt my flow between the time I leave my car until the time I'm at the gate checking in. And that's an example of a flow system that has been designed so that everything can flow perfectly into the area where they leave the plane, or when they depart the plane, go back to their cars. It's a perfect system. And it looks like a heart. You have blood coming in and it branches out, it goes to all these different places, in complexity, and then the complexity flies back down to, the aorta that spits all the blood back out. Perfect kind of system. So over time, these systems, like river basins, are just gonna flow out to where they need to go. And the reason why I'm mentioning this is because that's the way innovation works as well. You're going along, 3 years, 5 years, your business is growing, you're part of a business that's growing, and you see things that are just like, man, we keep running into this time after time after time, and we can't solve it. Well, all of a sudden, one day you pick up you know, an issue of Scientific American, or, you know, something that you read in a trade magazine, you're like, wow, that is a cool technology to solve this problem. If you don't go ahead and start thinking about it and integrating it into your business now, and you don't have to implement it now, it may be 2 or 3 years down the road, but you need to start thinking about that because everybody else in the industry is starting to think about it. Unless it is the trough of disillusionment and the, you know, trough of uselessness, in which case you don't have to worry about it. So let's step back now and talk about big data again. So big data is akin to, you know, you can map that over to like camera sensors. So in the old days, we had very limited resolution. You know, photography started off in black and white, and now we've got 50 megapixel, you know, images that you can see everything. I took this out in my front yard at a house I used to live at. Kind of scared, startled these deer. But, you know, so compared to the first picture, you know, you can barely see what's going on, and now you can see, like, you know, how their fur falls. And that's the same thing that we have in business now. And it doesn't matter what you're thinking about. It could be a physical area, it could be a financial area, it could be a marketing area. We have all the answers hidden in plain sight right there for you to take advantage of. So here's a system I kind of touched on really briefly earlier. This is a well monitoring system. I'm not real familiar with this particular company or anything. I just know that this is a really good application of big data. So it can show you, you know, how a weld is progressing. So imagine in a steel tank, you know, you've got a technician, he welds together, you know, this small tank, big tank, it doesn't really matter. But you now have all this data about all the welds in this tank. You can store that aside, you can do anything with it. Pattern recognition with artificial intelligence, because that's all artificial intelligence is pattern recognition. You could look and see, okay, what are the bad welds that we've experienced? How can we use that to make either better welds? Can we find out which technicians are better welders than others and maybe put them with some of the more junior welders? Maybe in 10 or 15 years, we find some anomaly in the data and realize that, hey, we either need to fix this or maybe it's a good example of something. But we have that data. We didn't have that before. You know, you're in the dark without this data. Now you have it, you can use it for something. So machine learning, I restarted a software company earlier this year that I started back in 2012 with a gentleman. Giving birth to it and got to get this thing going. Maybe I'll sell it one of these days or not. But it's a machine learning company. So I've been learning the math behind machine learning, and it's incredible. The one thing that I do know is that HAL 2000 from, like, you know, Space Odyssey, we don't have to worry about that anytime soon. It's very complex math, but basically it's just math that recognizes something. So a pattern, mine is going to recognize demand curves for advertising. And the way it does that is it says, here's 10 points of data that shows how advertising worked over the years. The math goes through and finds a pattern, and it gets to the end and it says, was this the pattern you were looking for? It says, no, that's not right. So make a note of it, take the error, go back to the beginning, do that over and over and over again until you finally get the right pattern, and then it recognizes it. That pattern has an error in it, and that's the reason why I know that outside of having a massive drones that could go kill somebody, you know, instantaneously, which, you know, is bad, AI is not going to take over our life, you know, with intelligence anytime soon. It's too complex. You have too many decision points getting to something finally, and as simple as having a robot do something, slicing bread they can do, but you know what I'm saying. But you take these algorithms, and if they're small, they're very, very accurate, and they can make decisions. Like I said earlier, if you have something that, you know, you only know it's going to make 4, 5, 10, 15 decisions, that's something that you can put into production and use. And right now they're using it in marketing programs, different products, Internet of Things. Here's another great example. Nestle wanted to figure out how to save money and also be more green in their water bottles. So they used a finite element system to go through their water bottle design and model the physics that hold water inside of a container. And when they did that, they found out that they could make a lot of this plastic very thin and still be strong enough to hold water indefinitely. And they saved a little over 5 grams of plastic per bottle. Now spread that over millions and millions of bottles they produce per year. That's a lot of plastic. So I'm sure they can turn that into a green story or whatever. But the fact of the matter is that they're using less resources, they're making more profit, and eventually, hopefully, they're passing some of those savings along to us. You could do that with a steel tank. As I mentioned earlier, the Internet of Things, PLCs, robots, you've got wearables and sensors. Maybe this is something you could think about as safety of your employees. Maybe you have, and I'm just spitballing here, this is all brand new stuff. You've got to think about it in your context. You have to think of the business problem that has to exist, but if there's something that, maybe heart rate of your workers, maybe they're working on a water tower, and they've got to, climb up high. I don't know, but you could use Internet of Things sensors that are available now to monitor the person, monitor their elevation, generates a massive amount of data. Another thing that you could do is there's a company in Atlanta that specializes in helping companies with several motors in the field that run water pressure meters. And they have sensors built into them that call back home, phone home, and they say, hey, sensor's running great, hangs up and goes away. After a certain amount of time, it's instrumented to start recognizing vibrations that are getting outside of the norm of that motor. And it calls a technician proactively, and then they go out and they change out that motor. But if the motor never phones home and says, hey, there's something wrong, then there's no need to go bother with that. So the customer experiences higher service because the motors never really went out. In their mind, they don't have downtime, so a motor doesn't fail and they have to have an emergency where they get the technicians to come out and replace the motor, etc. There's a company in Belgium, I believe this is where this was, that they're doing smart water monitoring. So they build the sensors into the tank and into the system. This is a way to expand your business. If you're only doing water tanks like my friend, maybe there's a way to go into the sensor business. You can expand your business, start adding sensors to the tanks. Find out what are your customers doing with your tanks. Are they monitoring the water? Are there certain particulates they want to know that are coming in and out? Could you put sensors on the bottom of the tank to start monitoring what kind of sediment it collects? Even in fuel tanks, diesel fuel tanks and sailboats, they start getting that little fungi or bacteria or something in the bottom. So you want to monitor that and say, hey, it's starting to build to a certain level. There could be any way to look at this, but they basically have it's a communications network, but everything's on their mobile phone, so they can tell what the water quality is of any of their tanks just by looking at their phone, drilling down into it. Is that valuable? I don't know. You have to ask your customer. It could be very valuable. Amazon's warehouse is really cool. Basically, these are all robots and rows of data. And here's something you wouldn't pick up by just looking at this image. The way they stock merchandise in their warehouses is, they don't put like all of the Post-it notes in one bin and all the memory sticks in another bin and all the cookware in yet another bin. They use a thing called chaos theory. And they'll split up all of these 3M bits and pieces and then put them into all different kind of containers. So one container may have a stack of Post-it notes, a knife, flashlight, it's all random. But the computer knows exactly where everything is. The reason why they do that is because all these little robots running around, you don't want them to run into each other. So I worked in a warehouse like right after college, and it was an old-fashioned arts and crafts warehouse, and you get a pick list from a school and have to put together a bunch of arts and craft supplies, crayons, whatever. But we had probably 15 pickers, and we'd all run around with, grocery carts and pallets and stuff and collect stuff. Well, if we ran into each other, like we always did at the construction paper aisle, you've got 4 or 5 guys just sitting there waiting for the one guy to get the rest of his stuff before the rest of them can get theirs. So it takes a lot longer in that environment. With the chaos theory, the computer can say, okay, I know that all of these things that need to be picked off this list can be picked off in this order, and I can keep the robots from running into each other as they pick it. So you get instantaneous, you can get them as fast as the robot can travel, for one. They have self-learning capabilities, so they kind of learn, the robots themselves learn how to be efficient. They use 3D, so you can take a robot up to a spot, go up 8 or 9 spots, grab something. Humans have to use ladders, and you can't just have a ladder at every single bin. So those are the ways to sort of think about it. That's really complex. I'm not going to break that down in an hour talk. But that's something that they're using, these new technologies, this new math is now possible because of technology. Random and chaos theory and robotics, that wasn't even possible 15 or 20 years ago. That's not that long. And look at the progression. That's what exponential growth allows you to do. Mobile, there's now more computing power, in your iPhone than, I had my first computer at IBM. It's just amazing. The whole NASA system, from space launches could have been run off a single iPhone. That's in your hand along with Bluetooth, wireless, it has a camera built into it. Apple has just released a whole new software toolkit that allows you to build machine learning into audio, the camera. So if you have something you need to recognize, another thing that Amazon does with their robots is they have cameras that they can look into that bin, and they know based on what the computer told them was in that bin, they can use their camera to recognize the patterns, machine learning, of what's in that bin, and they can reach in and pick the right one, take it out. So some of you that do quality control, that relies on some type of vision to look at something and determine if it's getting spec or not, you can train the computer, the camera, to look at and recognize a pattern of something that doesn't fit. Or maybe does fit and you're counting something. Or maybe you're tracking wells. FinTech, I'm going to cover blockchain, but one thing I want to answer real quick. The gentleman asked me earlier about staff and hourly rates and not being able to get people to come in. There's one system that has come out that some of the VCs and angels have been using for a while to build companies beyond where they've gotten to. It's really hard to cross that barrier from, say, 35 million to about 55 million. That's just the nature of the beast, and it has nothing to do with labor, which is getting harder and harder. But what they notice is that if you offer employee stake in the business, so if you give everybody a piece of ownership in the business, it sounds expensive. It's not, because technology is now allowing you, through things like blockchain, which I want to show you in a minute, to share the wealth in an automated way. And what they notice is the growth curve substantially increases. One company they used this with was a trucking company that was distributing out of Ohio, I believe. And they interviewed one gentleman who's a driver, and he said, in the old days, I'd go to the warehouse, pick something up, take it over to Illinois. And I come back to the warehouse, I pick something up, I take it over to Michigan. Come back to the warehouse, and it was kind of like spoken wheel. Well, he realized he could save the company after they made him an owner substantial amount of money if he picked up everything and then drove to Illinois and then Michigan, and then he got more time off himself because it was, he could deliver all of that in a shorter route, less costs, but you as the owner, you don't see all that happening. You're in your world up here. The frontline people are the ones that make the best decisions. If they don't have a vested interest, they may or may not make the best, decisions. But if they're an owner and they realize that if they do the right thing and you train them to understand how to run the business from their perspective, and that is now becoming possible because the financial systems are in place. Yes, 10 years ago, you had to have lawyers involved, HR, it was a pain. It wasn't worth it, now it is. So let's talk about blockchain. This is a really cool system. Most people think, how many think blockchain is all Bitcoin? Maybe it's good. Everybody's kind of come around. Originally, blockchain was associated with Bitcoin, and people didn't really make a distinction between the two. Bitcoin is an asset, it's an electronic asset. But blockchain was the real invention, I think, there, which is basically a distributed ledger. And I've written a couple of articles about this. Basically, everybody has a copy of the ledger for this asset. Your friends, your enemies, people who don't care. So it's next to impossible to steal an asset by changing the ownership of it, unless you do something stupid like leave your private keys and your password out there. That's the reason why you see some of these Bitcoin heists in the news. Someone leaves their credentials out in the open and you get it stolen. But for the most part, this works really well. And by the way, even if you steal some of these items off the blockchain, they can still trace the addresses. So they know where the asset is, they just don't know who owns it yet, but once they get that piece of information, then boom. So a distributed ledger allows you to exchange any kind of asset you can think about. A physical asset like a house. Housing is now, I think there's a company in, or actually it's a state, it's a township in Michigan that is allowing people to trade houses on the blockchain. What that means is, let's say that I own a house, I own the title of the house, and I want to sell it to somebody. I set up a mechanism for funding, transfer, and then I can transfer the address of my house to that person. I don't need a closing attorney, I don't have to do closing costs, I don't have to do title search. The title's right there, and you can see everything about that title right there on the blockchain. And everybody else has a copy of that too, so everybody knows. It's not like it's a little personal, private, accounting system that we have. This is a big, global, worldwide. NFTs, which is the artwork that you're hearing about these days, supposedly an artist can say that this is only going to be on this blockchain. That becomes a trust issue because you're trusting that the artist only has that one copy. And most of the time they're up and up, but there are some people who steal. What this does is it takes away the trust factor. And let me talk about that again here. So you have participants from all over the system. You have these assets that can be, like I said, NFTs, or they can be houses. They could also be parts. It could be welding machines. They could be valves. They could be sensors. They have serial numbers that were made by a specific person. You transfer the assets. So let's say you're building a big engine. I'm going to get to that in a minute. But it has all these different parts and components. Well, your suppliers can say, okay, here are all the components that I'm going to supply to you with their serial numbers and their history. They're going to be transported on this truck. And here's a good example. So Chick-fil-A created a blockchain to get chickens from the farm to the store. And one problem that they were having was if the chickens ever get above a certain temperature, you have to throw them out. They're no good anymore. So they embedded sensors into each one of these chicken boxes. I don't know what the hell to call them, but they're frozen chickens. So at the farm, they freeze them and put them in these boxes. They put them in these sensors, and then the sensors go on these trucks. Well, they can monitor the heartbeat of all those sensors. So every hour they get it, into a database. They get the big data that shows that either all these chickens are within the range of chill that they need to be, or they're not. Say that there's a truckload that the temperature briefly went outside of range, and then they got it back down an hour or two later. A less than honest truck driver may try to go ahead and pass that off as hey, these are good, they're fine. But they could look at that blockchain and see that, you know, the temperature went up for that period of time. They could say, no, we're going to reject this shipment. If they didn't know, if they didn't have that big data, they wouldn't have been able to make that decision to say, hey, we're not going to give you, I mean, we're not going to take this shipment and you know, it's your problem. Here's why. We can prove it. There's consensus protocol in that situation, obviously, because all the partners, you know, Chick-fil-A, you know, all their partners have to agree to this consensus protocol in the beginning before they even start. Because if you don't have all your partners involved and you all don't agree to use this system, you can't force it. So, you know, it's everybody decides we're going to put together this protocol of trust. We're going to instrument it, and we're all going to live by this. And it works. It works great. It works beautifully. You have smart contracts. A good example of a smart contract is one where Microsoft put together one of their latest games. And for one of the games, they have to use thousands of small independent developers and development shops. And in the old system, they had to keep track in accounts receivable, accounts payable, all of these thousands of vendors. So at the end of the quarter, you know, they'd get all the revenue in from around the world for this game, and then through the accounting systems, they would generate, you know, checks to go to all these different independent vendors. Now, they put that system on a blockchain. So the minute I say go buy a game for my son, you know, spend $100 on a game, that instant, the blockchain distributes it through the smart contracts directly to all those ISVs that work on that. So it's a distributed accounting system that has the smart contracts built on. It's the same as if you deliver a job. Once you've delivered the job, and it's according to the protocol, you can be paid. You can pay all your vendors. The customer pays you. There's a number of ways you can set this up. That's basically. You have provenance. So as I mentioned earlier, the engine. I'm going to get to that in a second. So we've already talked about most of that. So here's a great example of a good use of a blockchain. So I don't know if you guys remember, ladies and gentlemen, the jet engine, it threw a fan blade like 34,000 feet, and that poor lady was sucked out a window. And I think they tried to save her, but you know, that's just 34,000 feet. Rolls-Royce has now developed a system that they put the whole engine on a blockchain. So every one of those fan blades has a serial number. Every one of those fan blades is made up of a specific chemical composition of steel and alloys. And they can tell what percentage, you know, is in that. They know the name of the technician who built that fan blade. They know where it was built, what time of day. They put all that information, and every single one of the parts, turbochargers, whatever, that go into that engine lives on the blockchain. The reason why that's really important is because if that happens again, they could look at that engine, go all the way up to the fan blades and figure out the serial number of the fan blade that broke, and then they can know within 5 minutes the adjacent engines that were built with the same fan blades by that technician and that chemical composition. With the engine that did that, I think it was a different engine. I think it was GE, it doesn't really matter. They had to go back through all the paperwork. It took them months to trace their way through all the paperwork to find out, you know, which engines may also have that problem so they could go out and inspect them. Another thing that you could do with this blockchain is assets as a service. So a lot of people don't want to buy the asset anymore. They'd rather rent it from you. And I know some people are looking at this. I talked to a very large steel pipe manufacturer last year, and they're considering offering water transport as a service. That gives them control over the assets. They can charge the customer a certain amount of money, but they have control over manufacturing, maintenance, the whole 9 yards. So as I mentioned earlier, they instrument it, they could instrument it, they're not doing the shit, to see, you know, what are the parameters of a pipe failing? And how could we build it so that we would know in advance, like when we should go out there and service it? You can do that with the big data and pattern recognition. Maybe steel tanks are the same way. And with the welding data I showed you earlier, you can keep track of all the welds for a particular tank, have that tank on the blockchain, have all of your tanks on the blockchain with all the weld data. Let's say in 5 years you realize that there's a technique you were using that is probably less than ideal, and you know that some of these tanks may start failing in about 2 years. Well, if it's tank as a service or water or fuel or whatever is a service, you can probably schedule some time to go out there and proactively take care about it, and your customer may never know. Or customers love it when you come to them and say, hey, we're going to stop a problem that we created and help you. It's good for customer service. It's not good to go to your customer hat in hand, but you got that data. It's predictive. You can nip it in the bud before it even gets there. That's what's beautiful about blockchain. So eventually we're going to get to a point where we have everything instrumented. The whole supply chain, from supply chain to manufacturing, putting this information together, be on the blockchain. You can analyze all this data using machine learning, to go through all this big data, because you can't pay a person to go through all this big data. It's just impossible. You have to create, some kind of pattern recognition to find it, which is not that difficult either. You just have to. So this is just the typical speed and agility matters more than ever before. So you need to look at this as an opportunity when you see something like, man, I wish we could do it this way. Or look back, what are your customers buying? What do they do with your products? What are they doing to get to the point where they decide they need your products and services? And then after you've put something in, what are they doing with it afterwards? Look at that value chain and figure out, okay, can I expand my services by doing, something else? If I can, what small area can I start with to prototype it, just to see if it works? You don't want to boil the ocean. You don't want to just wake up one day and say, oh, the company's going to start doing this now. You need to start with a small project, grow it, make sure that everything is working properly, find the pitfalls first, and then grow it into something that the rest of the company uses. So imagine if you could change your supply chain like in days or weeks instead of months or years. Right now, that's a real big sore spot, because a lot of your parts and services, maybe not as much in the steel tank industry, but a lot of other industries, they've got things coming from China, obviously, India, the whole Russian thing. I mean, there's so many companies in Europe now that are affected by the war. People need the ability to change this. So blockchain gives you an ability, once you've got that system set up, to change suppliers. You have that trust that that part coming from, used to come from China, you knew the manufacturing process, you knew all the data about that part. Well, if you could find another part on the blockchain from, say, South America, you could switch it pretty quickly and trust that that part will be what you need, because you can see the provenance on the blockchain for that part. So just one kind of like bonus thought, I guess, is a lot of people are like, well, I don't know how to find financing for this. We don't really have any financing lined up for these type of projects. Think about finding finance with the 80-20 rule. And basically what that means is that 80% of your customers, 20% of your customers are going to supply you with 80% of your profits. And that also states that 20% of your customers are going to be 80% of your costs. There are always customers that, if you break it down into cost-based analysis, those customers are costing you way more than they're paying you every year. So if you just look through your accounting systems, you can probably find some customers that you should probably fire. Don't be mean about it, but just say, hey, you know what? I think that we've come to a point where I think, Joe over here has a company that, would be much better service, because we're moving here. You still need this. Get rid of these customers. An example, current results, for this one company, if they grew 10%, they grow the bottom line, but it's, they still maintain the same costs. Where if they look through and they try and cut some of their customers, their net profit goes up. And so then if they do increase sales, that number increases even more. This is really important if you're in a position where you want to sell your company at some point in time. That's going to result in a higher multiple, a higher valuation for you to clean up these customers. So something most people don't think about doing because they just think that, oh, if I decrease sales, there's no way I'm going to increase my net margin. Yeah, you won't. That's it. If there's any questions, hopefully I haven't bored you to death. There was just so much to cover in this, but hopefully I've, after this kind of sinks in for a couple of days, the gears will start turning. If you have any questions, please feel free to see me. So that's it. Thank you for your time. And one thought I had. Jeffrey, I know most CEOs miss the digital transformation is not just digitizing their businesses. It's exactly what I just went through. Rethink your business processes and then reconstruct them from the ground up. That's what digital transformation is. Now I'm good. All right.
Great job.
Thank you.